Hello, this is Jack Jackson. In this video we're going to be starting, or actually I'm going to introduce some problems for you that are review problems over Unit 3 on integration, definite integral concepts, approximations, and so forth, and definitions. And in this video I'm just going to introduce the problems. You can go through here and pause at different spots and work these yourselves. In the next video or two, we will work through the solutions. So here's the first of these questions. We're given a table of values here from an integrable function, and we want to integrate this from 2 to 20 using 3 intervals of the same width and work out what left, right, trapezoid, midpoint, and Simpson's rule estimates would be for that. That's L3, R3, T3, M3, and S6. Next, use the average value of 8x to the fifth minus 7 square root of x plus e to the x on to the interval from 2 to 10. Write out the integral expression for this. Don't necessarily try to simplify it, and then just approximate it. And you may use a calculator to do that approximation. Next, we have the integral from 2 to 14 of natural log of x over 11x to the fifth dx, and we want to integrate that using 18 subdivisions. That is L8, R18, L18, R18, T18, M18, and Simpson's 36. And you may use a calculator program on that one, which makes that one pretty easy if you've got the calculator program. Next, we want to show how we can approximate the integral from 1 to 3 of x to the 6 dx using a right Riemann sum with just 2 rectangles. So I want you to draw out the graph carefully on graph paper or a computer-generated graph and illustrate the Riemann sum and the integral on that graph. Show all the intermediate calculations, but do not use any calculator program. Do it completely by hand. And then part B, define algebraically what's meant by the definite integral in general, and being sure to define all of your symbols. Part C, use your calculator to approximate the integral from 1 to 3 of x to 6 dx. Show all the digits given by your calculator. So for problems 5 to 6, set up an exact value for the solution in integral form, but don't try to find it exactly. Then use the numerical integration capabilities of your calculator to approximate the solution. Show all the digits given by your calculator. Number 5, the population of a certain region is growing at a constant relative rate of 4% per year. Note that's a relative rate, not a continuous rate. Its current population is 861,752 people. What is the average population for the next 15 years? Next, we want to look at the velocity of a particle moving along the x-axis is described by the formula v of t equals 12 minus 3t cubed, where v is the x-coordinate of that point. And the particle starts at the origin at time t equals 0. Actually, v is not the coordinate, v is the velocity. X would be the coordinate. What is the net change in position of the particle from time 0 to 20? What's the total distance the particle moves from time 0 to 20, and the net distance as the particle moves from time 0 to 20? And see if you can just work out those 6 problems. Come back in the next video, we're going to go over the solutions to those.